Hi everyone, this is the second video of the normal distribution. In this video, I will be talking about the standard normal distribution, standard normal table, finding normal proportions, and finding a value given a proportion. My next question is, what is the standard normal distribution? Before I go to the standard normal distribution, let me remind you the normal distribution. Normal distribution is bell-shaped and has two parameters, mean mu and standard deviation sigma. The standard normal distribution is also bell-shaped, but mu equals 0, sigma equals 1. This means mu mean equals 0, standard deviation equals 1. Again, if standard deviation equal 1 and mean equals 0, that should be the standard normal distribution. Numbers on the horizontal axis of the standard normal distribution should be similar to this. 0 is the middle, positive numbers at your right, negative numbers at your left. Next is z-score. If x is an observation from a distribution that has mean mu and standard deviation sigma, the standardized value of x is x minus mu over sigma. We use z for the standardized value. So x is a number, mu is the mean, and sigma is the standard deviation. This z is called a z-score. The standardized version of any variable has mean 0 and standard deviation 1. It means z has the standard normal distribution always. Here we do have two density curves. This is the density curve for the normal distribution, mean mu and standard deviation is sigma. So this is the density curve for the standard normal. So mean equals 0 and sigma equal 1. Now we do have two values on this axis, A and here B. How do we convert this A to the standard normal, which is Z value here? So equation we use x minus mu over sigma, that is the Z value. Therefore x equal A, mu is this, sigma is here. Therefore our answer is A minus mu over sigma. Same way B minus mu over sigma. And this area under the curve and between A, B is the same to this area. Standard normal curve between A minus mu over sigma to B minus mu over sigma. Let me explain this example. Suppose a population was normally distributed with mean of 10 and standard deviation of 2. What is the z-score for 16 and 4? X has the normal distribution, mu equal 10 and sigma equal 2. So we have one x value. So x negative 16. So how do we find the z value for this x? Z equal x. X is here negative 16 minus mu. Mu is 10 over sigma. Sigma is 2. Negative 26. Next, x equal 4. What is the c value for x equal 4? So z equal x, x here 4, minus mu, mu is 10, divided by sigma, sigma equal 2. So this is negative 3. Areas under the standard normal curve. First, let me consider the area under the curve and left to the z-value. Consider this example. If z is a standard normal variable, find the probability that z is less than 1.13. So this is standard normal probability. Therefore, mu equal 0, sigma equal 1. Less than 1.13, 1.13 greater than 0, therefore I pick this point 1.13. So probability less than 1.13 mean the area under the curve and less than 1.13, this area. How do we find this area? Before we find this area, let me explain the z table. So this is the z table. This graph gives the area from the left hand side. And if you go to this table, you see z value over here. It means this column and this row gives the z value. Numbers with 4 digits in the middle of the table are the areas or probabilities. The first page of the table gives the negative z values and probabilities corresponding to those values, and here same but positive z values and area or probabilities left to the z. Okay, now go back to the example. So what we need to find the probability z less than or equal 1.13. Compare this density curve with the density curve of the z table and same direction. So we need to find the probability z less than or equal 1.13. So go to the 1.13. For the z value, you see here 1.1, but we need 1.13. So 1.1 is here and 3 is here. So if you go down and if you draw this line, then this is the number at the intersection. It means 0.8708 is the area under the standard normal curve and less than 1.13. Now consider the area right to the z. If z is a standard normal variable, find the probability that z is greater than negative 2.36. Standard normal, mu equals 0 and negative 2.36. Probability is the area under the curve and greater than negative 2.36. Z table gives the area left to the negative 2.36. Red colored area can be observed from the table, but we need the blue colored area. So how do we find it? The whole area under the curve equal 1, and we can find the area left to the negative 3.6. Then subtract from this. It means I can write down in notation probability z greater than or equal negative 2.36 equal 1 minus probability z less than or equal negative 2.36. Okay. To find this probability, we have to use the table. Go back to the z table and negative 2.3. Negative 2.3 is here and 6 is here. So we do have 0.0091. So 0.0091. Therefore, this probability equal 0.0009. This is the probability z greater than equal negative 2.36. Keep in mind, if you have greater than sign always gives the 1 minus probability less than sign. As a theory, you can say probability z greater than or equal any number. I just use a on 1 minus probability z less than or equal a. Now you can go back to the table and find the probability of this probability z less than or equal a, then subtract by 1. The last one is finding the area between any two z values. If z is a standard normal variable, find the probability that z lies between negative 1.10 and negative 0.36. Negative 1.10, I use here negative 1.10 and negative 0.36. So they are asking the probability in between this, mean the area under the curve and greater than negative 1.10 and less than negative 0.36, the blue colored area. How do we find the blue colored area? First, find the area less than negative 0.36. We can use the table to find this area. And then I find the area left to the negative 1.10, this area. I find the big area first, it means from here to here, and then find the small area from here to here. So then if we subtract, I can find the area in between negative 1.1 and negative 0.36. Now I can write down probability negative 1.10 less than or equal z less than or equal negative 0.36 equal probability z less than or equal negative 0.36 minus probability z less than or equal negative 1.10. Now to find these two probabilities, we can use the z table. So let's go to the z table. Use z negative 0.36, here negative 0.3 and 6, here is this 0.06. So the number should be here 0.3594 minus z less than or equal negative 1.10. Negative 1.1 is here, 0 is here. So you see now 0 is this. So 0.1357. Once you subtract 0.1357 by 0.3594, you will get 0.2237. We can write down this probability Z1 less than or equal Z less than or equal Z2, Z1 and Z2. So this meaning area in between this. This equal probability Z and take the bigger number first. Z less than or equal Z2. Always we take the bigger number first. Then minus, go to the smaller number. Second, probability Z less than or equal Z1. Consider this example now. Probability Z less than or equal Z1 equal 0.3256. So we need to find the Z1 value. The half of the area under the curve is 0.5. Therefore, I can mark 0.3216 like this, and this is the number we are looking for. How do we find this? Using Z table. If you go to the Z table, and we need to find this number 0.3256. Go to the Z table. Now scan the middle of the table for 0.3256. We see here 0.3264 and this one 0.3228. So 0.3256 is not here, but it is close to this number 0.3264. Therefore, Z value corresponding to this number is negative 0.45. Negative 0.45. So, go back to the problem. Therefore, we can say Z1 equal negative 0.45. Yes, it makes sense because this is the 0 over here. So, these numbers should be less than 0, which is negative. The last example, probability Z greater than equal Z1 equal 0.2267. Here we know the probability, which is area under the curve, and we are looking for the Z1. So this is the density curve for this is the Z1, and area should be greater than part. As you know, we cannot use the table with the area right to Z. Again, we can use the theory. Here we know whole area is 1 and minus, we know we can find the area less than Z1, this area. We can use this to solve this problem. Let me show you how to do this. So probability Z greater than or equal Z1, this can be written 1 minus probability Z less than or equal Z1. Z greater than equal Z1, this area equal 1 minus probability Z less than equal Z1. Then we can get this area. So this is given 0.2267 and 1 minus probability Z less than or equal Z1. Therefore, probability Z less than or equal Z1, this equal 0.7733, and this go to this side become positive, and then this go this side, then 1 minus 0.2267. Now go back to the table, and we need to find the 0.7733 in the middle of the table. 0.7733 3 we can't find again this 0.7733, but we can find the closest number is 0.7734. So this is the 0.7 here and 0.05. Therefore answer is 0.75. I can write down Z1 equal 0.75. In my next video, I will explain some examples. Thank you for watching this video.